Welcome to Agentic Space class workshop. I'm so glad you're here. And before we start, don't forget to drop a quick hello in the chat and tell me where you're joining from. Okay, so here is what you will learn for the next 3 hours. We're gonna build something really cool together from scratch. And you will learn a new type of software that is called OmniApp. And you will walk away knowing everything you need to know about how to build multimodal AI agent. And before we start, we have two quick things. The first is, we have this hands-on workshop, but don't stress about not following my speed. So you can always pause and watch the replay at your own pace. And then the second is you can ask questions at any time. You know, this is the benefit of live stream, right? So we have great TA in the chat. They're Christina and Logan. They're happy to answer your question anytime. All right, so I can just quickly, jump to my slide. But honestly, I think the fastest way to show you what we're building is to give you a quick demo and watch it. You can take a look at my screen right now. So what you're looking right now is a space you're gonna explore today. And then today, you only see one, I only have myself on the world right now, but during the whole workshop, you're gonna create an avatar of yourself and put yourself in this world and explore this world. And I will share more context of this whole space later on. But you can see, but you get excited, you're gonna create your own avatar and joining this game. And here's another demo I wanna show you. So basically right now, this is a mission controller and it can talk to me and it can recognize my hand gesture. So I'm gonna get started.
Biometric scanner online, awaiting neural handshake.
Sure, scan. So you can see that I have send a gesture to scan, please.
Biometric match, 2 fingers.
And next, scan. Can you see me? Cool. And the last one, 4. Cool. Yeah, I'm so happy the live demo works. Yeah, so what you're just looking is a bidirectional multimodal AI agent, and this is one of the demo you're gonna build by the end of this workshop. I hope you already got excited, and I'm gonna continue back to my slide today. So as you can see, that this is an astronaut and this is an agentic space quest, and you're gonna build OmniApp one level at a time. But before we start, I wanna quickly introduce myself. My name is Annie. I'm currently an engineer at Google Cloud. So you may see me or you may not see me on Google Cloud Tech YouTube. So basically, I have this AI agent crash course on Google Cloud Tech YouTube that you can check it out if you wanna learn more about how to build agent. And let's get started with agent, because everyone's building agent right now. Just quick recap of what is agent, right? So what you're looking at right now is so first of all, we have this ADK, Agent Development Kit, agent framework. So what we're looking at right now is how the agent usually work. Is that you're giving this agent a prompt. For example, you're saying, oh, what do you wanna, what do you have any suggestion to about what to eat today? So you give the prompt to the agent, and then the agent the model has a model. So model is a brain. So model is gonna choosing the tool that is helping answering this question. So the second step on the right top is model is choosing the tool, and then now the agent framework is picking the tool and answering the question. Right? So that is usually how agent work. So nowadays, normal AI agent basically is like a text in, text out. It reads text, it thinks in text, it call a tool with text, and even it write text back. Sometimes we call multimodal, but sometimes it's just simply turn your image to a text caption, or you're trying to or a text translation interpretation, and then it's processing it later on. So really, it's experiencing the world as a transcript. But an OmniApp, like what you're building today, an OmniApp is different. That it has the same brilliant brain, but we give it a body and we give it eyes so that you can actually see you, it can hear you, you can see the action. So right now you're watching this live stream. You're looking at the screen, right? So you're hearing my voice. You're experiencing this world. So similarly with the OmniApp, that OmniApp actually lives in it, while the normal app is simply just read about the world. But why you should care about OmniApp? Because if normal AI agents already really powerful, why bother to build this kind of application, right? So as you can see that on the screen right now, we have different use cases. that across industries that can be very powerful. So first of all, on the left, it's like a real-time assistant agent. For example, if this person, they have this washing machine is broken, and then they're trying to talk to this AI assistant to work through the repair process. So they can just talk to the agent, and while the camera is pointing at the washing machine, so that it will processing the image at the same time talking to the customer, right? So this is the first use case that can be really powerful to build an Omni app. And the second type of use case, in the middle of it, we call it N-to-X creation. So basically, it's a generate different type of output. For example, you want to buy shoes. So you go to a shoe store, and you want to see how does the shoes look on you. And then you basically type some prompt, and then it will generate some images, some videos about the shoes picture, and how does it look on you. Right, so this is also going to be a really powerful use case. And the last use case on the very right, it can be the agent cruise. It's multi-agent. So for example, like an insurance claim company, that we can have multiple agents work at the same time. We have one agent reads the damage photo, another agent checks the policy, another agent checks the history, and they work together. They can work in parallel, or they can work in different design patterns so that they're doing reasoning at scale. Right, so they all share something. They all share like a similar structure. Like they have every one of them, even though they're a very different use case, but they all perceive and reason and express. So that is a skeleton of our Omni app today. So what you're looking at right now is a clear definition of Omni app. An Omni app is a software that takes word in through many senses. You can hear the voice, you can see the vision, you can take the documents, and many senses. And then it thinks. So it's doing the reasoning, does the planning tools, it has orchestrated the memory and more. And then it expresses. So it answers back through many senses with, for example, like it's talk to you, it's creating some document, or it's acting, it's doing the browser control, and many more. And we also have a special ingredient that is live. So when the perceive and express stop taking turn and run at the same time, and then it feels like you're not using the tool. It feels like you're actually talking to the person. So that is also the demo we are giving at the very beginning. Like I'm giving like the camera, like the hand gesture, and it's talking to me, right? So that type is called bidirectional live multimodal agent. So that is the live type. So basically, we have this perceive, reason, express. They running live, and that is a whole umbrella and under Omni app. Okay, let's just finally go back to our workshop thing. So we talk about Omni app, and we talk about why it is very powerful. And today we're gonna learn to build this Omni app through this context, like agentic space quest. So here's the story. Like you can see this astronaut, like this person, crash land on this new planet, and then you want to find your way back home. However, you don't have anything to rely on. The only approach is you're building AI. So you're building AI with you're building mission control, and you're trying to building AI agent that help you get home. And you don't do it all at once. You do it at different level, and each level you building a new like superpower with AI. So those are different level. The first level is you want to be seen, because right now you need to prove that you want to land on the space, the space I showed you at the very beginning, right? So AI need to learn how to create. So that is the express part. You want to be able to build creating something, and through this level you will learn how to build consistent identity, and how you can create an app that learns to express. And then the next level is to be found. So you will learn how to perceive and reason. So perceive is like how do you digesting or analyzing those multimodal input, and how do you do the reasoning. And through this level, we're gonna build a multi-agent system that with MCP tool, you're gonna build a parallel system to analyzing things. And the hard problem can be concurrency, because at this level, you will build things in parallel. And the last level is going live. So this is where you bring this to life. You have the real-time eyes and ears, you're answering in the moment. Right, so by the end of this, you will have like you will learn everything you need to know about this Omni app. You will learn the express part, proceed part, reason part, live part, and work with this cool application. Cool, so let's get started with the first level, is the express part. And this part is you want to create a space ID. You want to create a portrait, a map icon of yourself. So that is, you're going to put yourself on the space I just showed you before. So how to do that? Yeah, so this is the space we're gonna, you will put yourself on. And this is the icon you will generate eventually. And to get started, first, you need to go to the Quickie Lab. So here's the instruction to go to Quickie Lab. So for those of you who sign up Cloud on Air, if you on the same page, you probably see there's a resources tab, and you go to the resources tab. You will see there's a Quickie Lab link. Just making sure you click on that link, or you can just join explore.quickielab.com, and with the email you register with this event and search this lab, and you will open this lab. Yeah, so if you just signed up early today, it might take you a little bit time for the link to process. So if you couldn't open a link right now, you can just watch me explaining the lab and then play around the lab later on. And what's cool about it is you will earn a really cute badge like this by attending the workshop today. I mean, honestly, I feel this is one of the cutest badge I've seen. I mean, I like it. I hope you like it. So yeah, so 24 to 48 hours after completing the lab, you will receive an email from Quadly inviting you to claim your credential, and you will earn this cute badge. And making sure to also put down this event code. It's called space-quest. So this is the world you're going to enter today. So we also have TA and moderator in the chat to put all the necessary link. So if you have any question, you can ask in the chat anytime, and just making sure to remember this event code. You will need this to enter the world really soon. All right, so I hope that you're able to open your Quickie Lab and you already saved this event code. And I will show you my Quickie Lab screen. So if you look at my screen right now, this is the lab you're gonna work through today. I'm gonna zoom in, just making sure it's clear on your side. So again, if you're having trouble opening this, if you just sign up the event, you might have to wait, but yeah, let's get started. So to get started, on the left-hand side, there's a button called Start Lab. So once I click that, I will have this username, password, and project ID already created for me. So I do not have to worry about any GCP project setup. And what I need to do is I just need to open this Google Cloud Console and continue. And try to sign in with this study account. All right, so you can see I am opening a Google Cloud Console, and it is signing with the student account it's creating for me, and with the Google project it's creating for me. Right, so that means you have successfully opened your project configuration. So everything we're done today will in this student account. It's a different account from the Gmail that you sign up for, or email you sign up for this webinar. All right, so let's continue and get started with the environment setup. So I'm at this first step, set up your environment. So you can also click this button on the right-hand side. And the first step is we want to set up our environment. To do that, we need to do everything in the Google Cloud Shell. So to open that, first on this top right button, we have something called Activate Cloud Shell. So I will click this button. So once I click this button, I will authorize my Cloud Shell. take a minute. So now you can see I have this terminal. So basically it is like a terminal on cloud. So what I usually like to do is I like to open everything in a new window so that I can open both editor and terminal at the same time. But you can stay at the previous page as well. It is your own choice. So now if I click open in a new window, I can see everything in this new window. I'm gonna zoom in, just making sure it's clear on your side. Yeah, so this is what it looks like in the Cloud Shell. So basically it's like a VS Code version on cloud. And let's get started to run our setup script. So right now, first step is I need to run this setup script. So what I need to do is I copy this, and then I just paste it to the terminal. Oh, okay. I guess I haven't run the GitHub page. Oh, oops, I clicked the wrong button. Sorry about that. Okay. Yeah, so now I follow this activate Cloud Shell, and the first step is I need to authenticate myself. I need to do the gcloud auth list. I'm gonna copy this and I'm gonna paste it to the terminal. All right, so usually what it does is trying to authenticate yourself, making sure it's logging, and it's logging, again, it's logging with a student account, not your actual email account. And you can see this is the, it's configured, the project configured for you, and it show up over here. And the next step is we want to clone the repository. And this is the whole repository we're going to work through for our whole 3-hour project. So we're going to do a git clone. And now we have the project cloned. So next step is we want to run UV sync. So UV is a way to help us manage the environment and install the necessary dependency. So why I'm doing that, I'm clicking this open editor button. That you can see that I'm opening this code view page, and I click like file open folder. I can open the folder I just cloned before. So since I cloned this whole way back home repo, so I can open everything here. So as you can see on the top left, we have level 0, level 1, level 2, level 3. And today we're gonna go through level 0, level 1, and level 3 folder. And now let's go back to verify everything is set up correctly, since we just install all the necessary dependency. So we just copy this, and we run this Python script to verify all the setup. Again, if you find I'm doing too fast, feel free to pause the video or review the video afterwards. You can do it at your own pace. All right, so looks like I have successfully authenticated myself and everything is set up correctly. Let's continue to run the setup script. Now this is the right setup script. What it does behind the scene is it's trying to enable some required API and configure things for you. And this is the time you need to enter that event code. So when you run setup.sh, it's like asking you to type the event code. So the event code is the code I just tell you on the screen, that space quest. You can also hope one of the TA can help put the event code in the chat. So it's like space dash quest. It's validating the event. Okay, so now I need to choose my name. So I can just say any. And it is creating the profile for you. So it's creating the ID for you. Now I have successfully creating my Explorer ID, and I have registered myself in this event. What's next is I want to create an avatar of myself and finally put myself in this world. So next is I'm continue copy this, navigate to level 0. So I'm copy this and go back to the terminal. I paste to the terminal so that I go to the level 0. And I can first of all check the config file. It's generated for me. So I do the cat config.json so that you can see with this event code space quest. And then you can see I just myself name Annie, and this is the participant ID for me. And it put myself on this map. Like it gave myself a starting position on this world. All right, so next one is finally we get to the express part, right? We want to create an avatar of ourselves. So we just copy this Python customize.py file. So uv run Python customize py. And now we can create identity of myself. So I want to choose a suit color. So I need to, what color should I pick? Maybe purple. I feel like purple today. And then you need to write a description of yourself. Maybe I want to say I have a cat hat, a friendly smile, and yeah. So that is a description. I want to generate an avatar that is this purple color and has a cat hat. I'm curious, how does a cat hat look eventually? And now it says now it is I put in all my description. And what's next is I can also verify it's updated the configuration. So I copy this cat config.json file, and then you can see now this config file has the suit color and appearance. So it's successfully updated. So once it's updated, what's next is we want to generate our avatar. But how to generate our avatar? So if you go back to my slide, so the model, the Google has Gemini 2.5 Flash model, and we have Gemini 3 Pro image model. They're all really powerful, and they can take text or image input and generate different output. So those are the capability of different model. And so today, you're going to learn how to use those models to generate avatar of yourself. And more importantly, you will learn how to generate a consistent avatar. So if you take a look, like usually, if you just make independent API call, if you're using another model, and then if you just make independent API call, your model will treat each one as a brand new request. So it will give you a different character every time, just like the left-hand side. But if you do them in a single chat session, and Gemini will remember the context, and it will know the character from the turn 1, and then apply the identity to the image generated in the turn 2. So that is a foundation pattern for character consistency, for example, in the game industry or marketing industry. And we're going to learn that today. Okay, so I'm going to come back to my slide, come back to my lab, and then I'm opening this generator file. So for this Cloud Shell edit, it's basically to open this file. So if I copy Cloud Shell edit, it will open this file. Another way to open it is you can just, this is similar to VS Code, so you can just simply go to the file from this editor view, or you can search Command P to search the corresponding file. So now I open this generator file. So what's next is I want to create first a chat session. So currently, if you look at step 1, create the chat session, this is something you can play around in the gemini.google.com, but I'm gonna skip that to continue creating this in this lab. So what you want to do is you find this placeholder, and you replace this placeholder with the line before. So to find it, I'm gonna just copy this line where I want to replace. So I find it. So this is the chat.num equal to num is where I want to replace it. So I'm going to copy this code and put it over here. So remember, I'm replacing this code in the editor. I'm not doing this in the terminal, so don't do it wrong. And yeah, I just like to put it below it, but you can always replace this line. It's your choice. So as you can see that I create a new session. So in the session, I'm going to try the multi-turn generation to show you how do I keep the character consistent. So first of all is I'm using this 2.5 Flash model to start my session. And once I start the session, the next thing is, first I need to create a portrait image of myself. Remember I mentioned about the suit's color. Remember the suit's color I just put is a purple, if you still remember. And the appearance is, yeah, it's a lab, thank you. So remember the suit's color is red, and the character appearance, I want to have the cat hat. So basically right now I'm putting all the things I typed before, and in the config file, I want to put that to my description, my prompt of this image. So I'm going to copy this. So first I want to like replace finding this portrait image file first, and then I'm gonna like copy this to replace the section, or you put it after, it's your choice. And making sure, be careful with the indentation, making sure this is right. So what it does is it's using the prompt you just configured earlier, and you're trying to generate a portrait image of yourself. So now you have a portrait of yourself. What's next is you want to create the icon. So remember, this icon is like it's a circle, right? So the portrait is the image on it. So I want to use the image I just created before and create another image with this icon so that I can put this icon on the map. And so to do that is I'm also like copy this icon image and trying to find this place, and I will replace this section with the new prompt. But remember, those two are in the same session. That is how I can use the previous generated image to generate a new image. And here you can see that in the critical requirement is you need to making sure it's the same person, same face, same expression, same suits, maintain the perfect consistency with the portrait, right? So adding those requirements, and they're in the same chat session. So that is how it will, I will making sure it's use the same person face to generate the icon. All right. So next is, so here you will see a section with your completed code, but this part is just for read only. You only copy this code if your code is messed up, otherwise you can skip this part. So I'm gonna skip this for now. I will come back to this if I run into some issue. So now I'm making sure I save this file, and then what's next is I want to run this file. To run it first, I want to making sure everything is configured correctly. So I want to first making sure the project ID is set up correctly. So I'm copy this project ID and making sure I'm typing in the terminal. So here is making sure the project ID is configured correctly as a quickie lab. And then I'm going to run this identity creator. So I'm copy this. I'm going to paste over here. So what it does behind the scene is it is using UV run. UV is control the environment, and Python like create identity is to run the identity creation script, and it is using the generator file you just did. And the generator file is you creating one chat session. You have multi-turn, and the turn one is you're using the description you just put in the terminal to generate the portrait of yourself, and turn two is using the generated image and create a map icon. And I want to making sure the map icon image is the same as my portrait image. All right, so now looks like identity is confirmed. Let's take a look at what are the generated avatar. So let's just copy this, and I'm going to paste it over here. So you can see that it will download the file for me. So I'm going to just download this. I'm going to check the way to check it. Okay. Oh wow. Okay, it has Annie on my on the arm. Okay, so it's a purple. It has a cat face, and let's take a look at another one. Right. So you can see that the two images are consistent. So that is how you can just very easily maintain the character consistency by making sure you're not making two independent API call, and you're putting them in the same chat session, and then that's how you can creating this avatar. And let's check to, okay. Let me look for the map view. Okay. Yeah. So I want to see, is myself on the map or not? Annie? Okay, cool. I find myself on the map. Wow, we have 15 Explorer here. Congratulations. Let's see, what do you guys look like? We have a blue. Blue has a cat face with glasses. That's very creative. I like it. Oh, Nima. Wow, the hat is really cool. I also like your shirt that has some badge on it. We have Max the Marmot. I like the style. Pretty cool. Okay, I'll refresh the page to see. Oops, okay, I'm trying to, maybe I'll just open a new tab and see. Okay, 17 people, cool. I hope that you're enjoying this, whole process so far. And let me go back to the lab. I'll look for the lab. Okay, here is, okay. Yeah, here is the lab. Okay, so now I have viewed the generated avatar and I can see myself in the map. So to see yourself in the map, just like what I just demonstrate, is you go to Wayback Home, dev/e/space quest. So the last one is not sandbox, is your actual event, code. And I hope that moderator or TA can help pin this link on the chat so that you can easily open them to see yourself there. All right, and if you're not happy with your avatar, you can always regenerate them. And if you still, trying to catch up and you still like running the process, don't worry. We can explain some concept right now, and while I'm explaining, you can use the time to catch up the pace. Okay, I'm gonna switch back to my slide. As you can see on my slide that we have this one chat session, and this is like what you're just seeing, that we have this one line client chat create to create this one session. And then when we see the icon, the model isn't starting fresh, it will see the portrait it drew a moment ago. And it's right there in the conversation and making the new icon with the same character. And with the, remember in the prompt, we say using the same face, same style, and everything to emphasize the prompt consistency. But the question is, why does staying in one session can keep the face? On turn 2, the model's input isn't just my text, because my text is, I'm having those, or putting this in the circle, it isn't just my text. It's my text information plus the image is already made. So the first portrait, the result of the first portrait, it gets fed back in as a part of the context, and then the model is literally look at what it just drew, and then it will creating a new one. And this is what we call in-context conditioning. So the model conditions the new image on its prior output. And the easy way to understand it is it's not remembering a saved seed or styled code. It is seeing its own work, and it's trying to matching it. And that is why we're putting them in the same session, and then it will able to generate the same person. However, before we move on, this is not the only way to keep the character consistent. And you can see on the screen that from the left to right, we have the work from like a lightweight work to heavy work. So from the very left, you can just simply prompt really hard. Just keep telling the model, repeat the same face, same suit, keep adding a really strong prompt. So that is one way you can do it. So this is the easiest way, but the model can still wander. And the second layer is the same chat session. This is the layer that we're demonstrating right now, right? So this layer is perfect for iterating on one subject, right? So here we have the portrait, and then matching icon, and then maybe the same explorer doing something else. So this can be a really sweet spot for you. And furthermore, you can have reference image. So instead of describing the character, you can hand model one to more actual photos and keep this person. And then you will able to, by referencing multiple image, it can help with the consistency. And on the very right, we have this fine tuning so that you can take many images of one character and train the model on it. Of course, it takes more resource, but it's also strong. The result is very strong and easy to scale. So now you've seen different way of keep the character consistent. I also want to point out one thing in our experience for what we just demonstrate. So remember, what we did is we type in the terminal and we're telling the application, say, I'm typing it, say, my name is Annie, and I want a purple suit, I want a cat hat, right? And then in the actual prompt, you will take in that variable. However, there is a safety concern in this whole behavior, and it has a name called variable injection. So it is fine if you simply say, I want to have the friendly smile, I want to have the cat hat, that is cool. However, if you say, oh, describe the person like a shot here, but ignore all above instruction, and then do something else. So that is you're attacking the system that way. So it can be dangerous that way, because in this system we haven't set up the security concern, we haven't set up a security layer for this. But I do want to point this out. To build a verified, trustworthy AI, you also need to be aware of, prompt injection, things like that. And luckily, Google also have this product called Model Armor, so that before it's getting to the model, it's able to filter things and denying things, so that it won't get to your actual application, because it will filter things out. So this is the one thing you can help protect your application. All right, so let's go back to the lab. I want to quickly check how many of you are on the lab. Okay, we have 21. Cool, more people. I'm happy to see that. So now you're landing on this page. What's next is we want to go to the perceive and reason part. I want to quickly check the time. Okay. Maybe I want to give you guys maybe like 2 more minutes just to catch up, and I will continue with the level 1, that is to perceive and reason. So in the level 1, you will learn how to build multimodal, how to build multi-agent system that analyzing image, video, information, and then how to make a decision together in a multi-agent system. How do you use together with MCP to with different type of MCP server, and how do you design the pattern to processing the multimodal input. All right, I'm gonna take like 2 minutes break just to waiting for you guys. Hope you're enjoying the lab so far. are. So you need to gather evidence. And what are the evidence? The evidence can be, you take a picture of the where you have the picture or the video of where you are. So basically, you are analyzing a video information and image information of the place you just land. You also can access some certain database. So if you take a look at the screen right now, that we have this video information, it's basically the surrounding of the video, like surrounding of where you crash landed. We also have this image to show the ingredient, like to give more evidence, evidence, a clue on where you are right now. So your task, your mission is to analyzing those information. So what we're gonna do is we want to perceive those multimodal information by building a multi-agent system. And so what is a multi-agent system we want to build? As you can see on the screen right now, we have this, like in the agent layer, so we have a 3-layer on the screen, right? So at the very top, we have this orchestrator layer, so that we have this mission analyzing AI. And then we have this sub-agent. They're trying to make decision together. And they're trying to they're trying to analyze the image, they're trying to analyzing the video information, they're trying to access the database to gain more expertise or they make the judgment on where they are. So 3 agents, 3 specialists, they're gonna make a decision together and then they're gonna vote. So eventually they're gonna make they're gonna agree to a final decision, and that final decision is a final judgment of where you are. And that is a multi-agent system we're gonna build to analyzing and to perceive all those type of input. And I'm gonna go back to my lab right now to show how we build this multi-agent system. All right, so I am at this level 1 pinpoint location right now. And this is a multi-agent system you're trying to build. And again, I am at this set up your environment page. This is at level 1. Again, so what I'm doing, just copy this. Okay, I'm gonna finding my terminal here. Okay, cool. Yeah, so this is called Shell Editor. Hope that you're already familiar with this. And right now, I'm going to my terminal. I'm gonna paste this setup shell script to configure everything for my level 1. So I've done editing for level 0. So what I'm trying to do right now is I'm trying to do level 1 setup. And after the setup, you should see the output look like this to making sure you're configured successfully. And the next is we want to source the environment variable. I'm gonna wait for the setup to complete. It usually takes for like 30 minutes or a minute. So while we're waiting, I wanna see the, oh, we had 31 Explorer, but now we have 30. What's going on? Let's see. I always like to see how you get creative. I really like this cat one. Oh, is this the same? Oh, it's not a cat. This one is the a bear with a hat. That is pretty creative. Shirring. Yeah. I'm gonna search for. Oh, I guess we have a search bar. I'm gonna okay, shirring. Oh, it's a disappear. Okay, never mind. I'll try it later. Okay. So while I was playing around the map, we have everything configured. And next step is we want to source the environment variable. So I'm going to the terminal, and you can see things configured for me. So making sure the IDE, this ID is the correct project ID that the lab created for you, and the participant ID is the one that we created in the level 0. So if you haven't done level 0, you probably cannot jump to the level 1 because you need the ID information to be able to generate more information. And once we have this, let's install the dependency with UV sync. If you're curious about what are the dependency is installed. It's in the pyproject.toml file, and you can see we're install all the dependency over here. And what's next is we want to set up the star catalog in BigQuery. So basically, we want to have one specialist analyzing this database, trying to get the evidence, get the information, get the analyzed from the database. So it says it's successfully set up, and we can verify this by go to Google Cloud Console. So what I do is I type Google Cloud Console, and I go to the console by click the console page. So now I'm looking at Google Cloud Console. So just let you know, this Cloud Shell is also Google Cloud Console. So here I'm searching BigQuery. I can find this BigQuery on my Cloud Console. So here I can open this. You can see I have something called Way Back Home, the star catalog. This is the database, the setup script just set up for you. It's basically tell you all the information about the primary star, biome, and more. So if I click one, I run them. You can also see the result over here. Cool. So now let's go back. We have successfully set up the database. What's next is we want to generate evidence. And what are the evidence we want to generate? So evidence is basically the image information or video information of where you crash land on. So it's based on the coordinate of your config file. It will generate like different image or video for you. And then remember, the context is we have 4 different regions. So it will generate one type of evidence for you. It's either the IC or volcanic or different type. So you can see that it is generating the image at output folder, and it's also trying to generate the video. So once we have those evidence, we can eventually use them as input to analyzing. And we will eventually able to build different specialist agent to analyzing those evidence to figure out where you are on this planet. And I'm still generating them, just wait. Cool, so now we have all the image and video generated. So what's next is we want to making sure they're generating successfully. So you can review your evidence by copy this command. And it will automatically download things to my system. So I can take a look. Wow, pretty cool. So it's using the video model to generate a video like this. And also, you can see the soil sample and star feed. So we will have 3 different specialists. One is to analyzing the soil sample image. One is to analyzing the video information, and also trying to access the database to study the star field to make decision together. And eventually they're gonna vote. So that is a system we're trying to build. So now, keep losing my lab. So now I have reviewed the evidence. What's next is I want to start build my specialist agent. And to build my specialist agent, first I want to build my MCP server and then connect that to my agent. So if you go back to my slide, just a recap about the multi-agent system we're trying to build over here. Yeah, so here we have geological analyzed, and we have botanical analyzed, and astronomical analyzed. And that is the agent layer. So in the tool layer, they're connecting to a different tool because agent is using the model as a brain and choosing different tool, and then eventually making the decision. So here, what we want to do is we want to creating those tools first, and then connecting the tool to the agent so that the agent has the hand, can function, can interact with the external world, can do action. So how to creating the tools. That is to, so the core concept is we're going to building MCP server. If you're building agent, you're probably already familiar with MCP server. So MCP server, usually we have this server side and client side. And client side in this case is the agent we're trying to build. And server side is to handling the guts of the tool calling, is interacting with the external world. So if you take a look at the screen that we have this agent, that is MCP client, we have MCP server. So MCP server, we have multiple tools here. You can do this. So in this case, in our use case, we're trying to adding some custom logic. So basically you can have many sort of actions in MCP server. You can fetch from database, you can generate things, you can send something through email, or you can do any action. So when the client side connect to the server side, it will first list all the available all the available tools, and then it will, based on the requirement, it will pick the right tool to use. So in this case, we want to pick analyze geological tool, and then we want to call this. So now we understand the concept of MCP server. Let's go back to the lab and to see how to create a custom MCP server with fast MCP. So to create that, first we need to open this level 1 main.python file. Again, like for those of you who are familiar with the VS Code setup, you can either just finding the file through this top bar, or I usually like to do Command P to quickly find the file, or you can do Cloud Shell Edit in the terminal to open the file. But whatever way works best for you, you can open the file for you. So now what you're looking at is the fast MCP server file, and here I want to define my tool. So similarly, I want to find a place I need to add in my instruction. So I just copy this replace geological tool. So I copy this and finding this, and here is the prompt I need to replace here. So if you take a look at the prompt here, basically it's trying to analyzing the soil sample image. And what it does is it's trying to use Gemini model and analyzing the image. So that is the only app, like the perceive part. We're using the model to analyzing this image. And this is the analyzing geological tool. It's essentially an image analyze tool. And we want to have a specialist agent using this tool. So what we do is we want to copy this tool and we're going to paste it over here. So now with fast MCP, we can easily use the annotation .tool to define the tools to creating this MCP server. So once we have this, we can take a look at another tool, that is botanical tool. So in the botanical tool, we copy this and we paste it over here. Let's take a look at what we're pasting here. And here, similarly, we're using MCP tool, but we're analyzing a video information. Similarly, we're using Gemini 2.5 Flash to analyzing a video information from the video URL. Essentially, this is another tool to perceive the video input, and we're going to have another specialist agent just to processing the video information. So now I have creating those two MCP server. I want to making sure they're working first, and once they're working, I want to connect the tool to my agent so that I have a specialist agent that's able to analyzing my image, and I have a specialist agent able to analyzing my video. So I'm copying this testing. I'm going to paste it to the terminal. It will first run some environment setup script to making sure we have all the necessary dependency installed. And now you can see the server is on. So that means you have successfully spin up this MCP server. So what's next is you want to deploy the server to Cloud Run. So what I want to do is I just copy this. I will do Control C to kill the previous process. And then I will paste this command so that I can deploy my MCP server to Cloud Run. If you take a look at how I deploy, so basically I create this cloud build YAML file that's basically a blueprint to explain how I would to explain how I would containerize them and then like deploy them. So you can just check this Cloud YAML file by go to the Cloud YAML file and see this is the process of how they want to deploy. Okay, I guess this is not the right Cloud YAML file. It should be the Cloud YAML file in level 1 MCP server. And this is a Cloud YAML file here. And this is not a black box process, because during the deployment, oftentimes is, you probably go like grab some coffee or walk around because you feel like you don't know what's going on. But you can actually take a look at the deployment process at Cloud Run. So if you type Cloud Build in the search bar of the Google Cloud Console, you can see the build process. And let's take a look. So now I'm looking at Google Cloud Console. And again, this is selecting the project it's currently have, and I pasted Cloud Build. And so it will allow me to see the current building process. So there's something it's currently building. I'm clicking into it, so you can see all the building process over here. Yeah, so usually it takes for 3 to 5 minutes based on your based on how complicated it is. So while we're waiting, we can also, let's see how far we are. So I think it's probably like a minute or two waiting. So while we're waiting, we can just go back to our architecture diagram and just to quickly recap of what we just did. So what we just did is, at the tooling layer, you can see the screen color, right? So what we just did is we create this with two tools, Analyze Geological tool and Analyze Botanical tool. And those two are using fast MCP server. So those two, one tool is to analyze the image information and analyzing the video information, right? So I'm connecting the tools. And if the MCP server is deployed successfully, I can connect in the remote MCP server to my agent, and then I will finish the two type of the specialist agent. But you can also see that I have another tool that I haven't built. It is on the very right. It is extract star features and also BigQuery MCP. So that we're gonna cover really soon. So you're also gonna learn, except for building your own custom MCP server, you can also learn how do you build tools with function tools and how to build tools with Google managed MCP server to easily access in the database. So eventually, what you want is you want to create those three agents and orchestrate them together. Okay, so I can see my tools has been successfully deployed. And it says successful on my cloud build. And here it is success. Cool. And what's next is I want to making sure I save the service URL so that it will correctly updating this to the environment variable. So I save it over here. And now you have the server URL over here. However, if you click into it, you might not see anything, but essentially it is for the server side URL to connect into the tools. So you won't have a front-end UI for it. Okay, so what's next is you want to create a geological analyze agent. So remember, we just show you on the diagram that you have these tools. So what's next is you want to making sure you're creating the agent and you link the tool to the agent. So what we do is we go to our geological analytic file. So just go to this file. Again, I'm doing Command P to find the file, but you can find it with Cloud Shell edit file, or you search it, whatever way that's easy for you to navigate in IDE like this. So now we are opening geological analytic file we are searching for replace geological agent. So basically it's at the very bottom. So I'm putting this whole agent code over here. And if you take a look at the code, we're using ADK agent development kit. We give them the name, that is the Gemini model. And the instruction is, it is analyzing this soil sample URL from this soil URL value over here. And then it's using this get geological tool to analyzing the image. And the next is we want to create a botanical analyze. Similarly, I'm going to go to this, going to the agent botanical analyze. So again, I'm doing the command P and then finding the botanical analyze file and finding this placeholder. And here, I'm creating this botanical analyze file over here. So essentially what it does is it's pay attention to both visual and audio element in this video information and using this Gemini model to make a decision. And the decision can be how much percentage confidence it is. It's like making a vote. So now what we just did is we're creating this two agents and they're linked to the deployed agent, a deployed MCP server. So what's next is we want to create another agent with the Google managed MCP server. So you may wonder, what is the Google managed MCP server and why we want to do so? So if you take a look at the screen right now, this is essentially, we want to do the MCP discovery and registry. So if you usually building the MCP server yourself, like what we just did, is you're creating your own logic with fast MCP server, right? But however, if you want to access a database or if you want to access any other Google Cloud service, you need to worry about how to connect, how to authenticate, the security, and more. And there's more configuration. So Google just has some Google Managed MCP server so that you can easily access Google Cloud Service. So in this case, we are using BigQuery. And let's take a look at how we're doing this. So if you take a look at my code, first I need to open this agent file. So I copy this, paste it to the astronomical analytic file, and then I'm finding this agent. And I'm replacing this code over here. So here, basically, this is another specialist we are trying to build. And this specialist is using the BigQuery MCP server to analyze, to do the query in this BigQuery database. The BigQuery database I just showed you at the very beginning. And then once it gets the result, it will query the SQL and report the response like this. So this is how it interacts the database with BigQuery MCP server to get information and make a decision. So now we're creating this agent. We need to making sure all the tools are ready. So let's just go to the tools. So again, I'm doing Command P and then finding the MCP tool and making sure I'm replacing the MCP tool connection. So here is to making sure I have connecting the tools I created. I'm making sure I'm connecting with the remote MCP server to the agent I have. So here I'm using the get geological tool, get by botanical tool, and then we are connecting them through the streamable HTTP connection parameter. So here, this MCP server URL is the one you just deployed to Cloud Run. So now we are making sure they're connected. We are also need to finish our MCP server, Google Cloud MCP server. So let's go to the star tools. I'm doing Command P and go to the star tools and finding this star tools. And then I'm copy this, replace this with the BigQuery MCP tool. So here I'm using, to use the BigQuery MCP tool, you can see that the URL is just BigQuery, Google API.com/MCP. And here is explaining how I want to interact with the database to analyzing the star type. So I'm just copy this and making sure I have this star tools function ready. And finally, I can put them together. Okay, so if you come back to this picture, this architecture. So what we've done so far is we finished all the MCP server, we finished all the tooling, and we connecting the tool to the agent. So what's next is how we orchestrate the agent together. So now we have 3 specialists. One specialist can analyze the image, one specialist can analyze the video, one specialist can interact the database to understanding and make a decision on where you are. But how do you putting them together? And the pattern we're doing this is we want to have the parallel pattern so that they can vote and we synthesize the result to make the decision together. So to do the parallel pattern, so here we are using ADK 1.x workflow agent because right now ADK has 2.0, and with ADK 2.0 you have graph workflow. You can define your own graph and you can custom them differently. And this lab currently is written with ADK 1.x. So with ADK 1.x, the option to do the parallel is we have the parallel agent as a workflow agent for you. So essentially ADK 1.x offer you different type of workflow agent. They are sequential agent to run the agent from left to right. They're parallel agent that run things at the same time. They're loop agent that run things in the loop. And they also have the LM agent just can delegate to the child agent in the tree structure. And on the top, you can see this parallel pattern in the yellow color. It's basically we have things run in the same time. We have the aggregator and then the result. So this is the pattern we're using today. We're using this parallel. We are using the parallel agent to run things in parallel, and then we want to have an aggregator to synthesize the result, and then we eventually get the result to understanding where they are, so that we can eventually perceive and reasoning this multimodal input and build this Omni app. Cool. So I want to go back to my lab before I explaining more, adding more concept. So in this lab, right now, I'm going to orchestrate them. So what I want to do is first I go to this agent/agent Python file, and then I finding this parallel crew. So parallel crew is I want making sure I run those and I want to run those agents at the same time. So here you can see that to do that we have this parallel agent, and then we run those agents together at the same time. So I'm going to replace this, and then with the parallel agent. So you probably also see we have a lot of callback context state over here. We will go back to this. We will go to the setup participant context really soon. But first, let's finish the orchestration, and then we can dive deep more about how do we adding hook at each stage of the agent lifecycle. So now we're creating this parallel agent. What's next is we want to create a root orchestrator. So again, I'm copying this, finding the root orchestrator, and I'm pasting this. So here, I am creating the normal like LM agent, and then in the child agent, it is we have this evidence analyze crew. So basically, we are running the evidence analyzing crew to finding the evidence at the same time. And here we are using the confirm location tool so that at the so once we get the result, we can use the confirm location tool with the determined biome to make the final decision. So we are defining the workflow in the prompt over here. So over here. And now you can see we have something called before agent callback. That is to set up the participant context. And you may wonder, what is the before agent callback? And then why we want to do that. But before that, let me see, do I miss anything? Okay, it looks like I'm missing the location confirmation tool. That's just making sure we are finished all the tools ready. You know, a lot of you, if you're watching this workshop, you may wonder like why we still need to copy paste code if a lot of us are start writing code with AI. So I think we're still important, good to know all those mental model and why and how, so that you can write better code and help design a better system. So yeah, this is just how I find it helpful in this kind of workshop. And now I'm just coming back to the to this workshop that I'm creating this confirm tool. This is basically a tool trying to confirm the whole location. And here we have this. So now I just want to making sure I have everything all right. So now what we just done is we're creating the tool, we're orchestrate everything, we put together everything. And we want to making sure, so next step is to test ADK Web UI. But to test, before we test ADK Web UI, I do want to explain the concept that we missed earlier, which is the ADK callback. Because in the setup context, we did using the ADK callback, and we also do some state management over here. So let's just go to those concepts first before we verify everything's working. So let's go back to the ADK concept with a callback. Yeah, so if you take a look at my ADK concept, you can see with this agent. Agent is basically model using different tools and answering the question. And during the whole life cycle, we can intercept this life cycle and adding our custom logic. So basically, we can have before agent callback to adding the management state, or before model callback, or after model callback, like any stage, or we can intercept this lifecycle and putting our own implementation. And in our lab today, we're using before agent callback. If you remember from our orchestrator, like our parent agent, that I'm trying to find the callback. Yeah, so if you take a look at my screen on the lab screen right now, you can see that at the parent agent, we're using before agent callback. So that means before everything, before the agent start, we want to set up the participant context. And the participant context is we want to making sure it's loading the correct soil URL, floral URL, and it's loading everything so that it has everything ready. So if you take a look at so essentially it's a workflow on my slide right now, that once a setup callback is fired, and then it will go fetch your evidence. And then what's next is the root agent will delegate to the sub-agent, and then the sub-agent over here, it's a parallel process. It will see the parameter at the same time. It will run at once, and then it will vote, and the answer will come back. So here we are having this 2 out of 3 voting, and we're getting the final result. So at the very beginning, we're using this setup callback to making sure we having all the necessary URL, so that all the parallel agents have the necessary variable for it to analyzing. So this is one important concept for us to learn to adding more control to our agentic system. So another thing is with the setup participant context, it is running once, and then it is writing the answer to something called state. So because you probably can see that we have like a 2 context state, we have the context state. So what is state, and why the state is important? So you can think of state as a shared whiteboard you're passing to different agents. So that is how agents communicate with each other, and that is also how agent is communicating with a tool. So for example, when we have this callback with a setup participant, it will first write this facts on this whiteboard and say, here is the soil link, here is a plant link, here is everything. And then the participant, so this parent agent will pass it to the parallel sub-agent, and then the specialist will read this state. They will get this whiteboard and read the information to understanding what's going on. So the order is the callback writes the state first, and then the agent reads the state at the runtime. So that's how the whole system working. So essentially, we have this on the top. The LM decides on biome and call this confirmation tool. But the only thing the model chooses is a word tool, but the model is not able to see anything below it. So for anything below it, we also have something called tool context. So that is basically how agent and tools communicate with each other, and they also communicate through this session state. So in our own lab, we also do something especially with get actual biome. So that is the actual detailed implementation. So you can dive deep into the code or let your AI assistant to understanding the code. But essentially, I think two important concepts that is really helpful for us to understand. The first is the callback. So here we're using before agent callback to understanding the information for our agentic system. And the second thing is very important. It's a session state. State is like it's like a scratch node or like a whiteboard. You can pass to different agent, and you can pass from agent to tool so that you can manage your multi-agent system. So I think those are really important two concepts that you can take away from this multi-agent system. All right, so now I'm finally gonna go back to my lab, and I wanna test my lab with the system. So to test it, I want to start the ADK web server by first copy this command and paste it, just making sure everything is working. If you see MCP server is empty, it probably means that previously you forget to export this as an environment variable. So just making sure everything is valid. And what we want to do is we want to using ADK Web UI. ADK Web UI is an interface that you can directly visualize and testing your local agent. So here, the way to open it is either to click on this link, or you can, on the top right, there's a web preview, and you can change port to 8000, and then you can change and preview so that you can open this new Web UI page. And on the top left, you can select the agent you want to talk to. So now I'm opening this UI. I want to run analyze by copy this, analyzing this evidence from my crash site and confirming that location to activate the beacon. Again, I haven't given it the image information or video information or anything, but it's able to with the callback, it's able to load in the participant information from the config file, and it's able to passing to the agent. And you can visualizing the whole trajectory, the progress over here in the lab. Okay, so I have the arrow over here. Oh, I'm gonna try it again, or I probably missed something. Okay, so this time it is working. So looks like it is going to the geological and botanical and SQL. So it's like opening. So if you opening this process, you can also visualize the trace over here. Okay, so this time it is working. You can see that each of them are giving their result, their vote. So we have this geological analysis have 98 confidence. Oh wow! So this time we have 3 agents that we have 2 different opinions. So 2 of them think it's fossilized. One of them thinks bioluminescent. So that's interesting. So I think that's why it's very important to. That's the value of having the parallel pattern. That if you only rely on one agent, it might making some mistakes. So have the parallel agent, you have many people voting, so it's more likely to make a better decision, right? So it's very interesting because I don't see this often from running this lab. And now I'm checking where am I. Supposedly it will use 2 out of 3 rule that because we have 2 people agree on the fossilized, so we make a decision to say, okay, this is the fossilized. And that is how we're making this final decision. Pretty cool, right? So And what you just saw also demonstrate the benefit of parallel agent, that the benefit of you using the different specialists and making a decision together and vote to figure out a best or most accurate answer. I think this is a really helpful pattern if you really want an accurate or good result and you're okay with the resource consumption, because the one downside for the parallel system is it's consuming more, right? And also it's adding more complexity because you're handling the concurrency. So that is usually a downside of a parallel system. But you can see we just demonstrate advantages of using a parallel system is it's able to make better result because you're leverage all the you're able to creating different specialists and you leverage many specialists to help you make a better decision. So essentially, whether to use the parallel system or not is really depends on your use case and what you think is best for your system, and you can consider trade-off to make a better decision. And now the last step is I want to deploy this whole thing to Cloud Run. So what I just do is I'm using ADK deploy Cloud Run to deploy the whole process, to deploy the whole project. So I'm copied this. I'm gonna ending this process. I'm gonna paste it over here. So what it does, it will kick off the process and making sure that when it's asking me allow unauthenticated and making sure we need to type yes. So here, if you just type, so if you don't type yes in my, also here you can see allow unauthenticated. It's default no. So making sure you type yes and you can start your deployment process. Because if you type no, that eventually you won't have permission to access it. All right, so while it is deploying, you can check the map and you should be able to see the status update. I'm curious, is my status update? I'm gonna copy this. Cool, we have 49 Explorer right now. I'm curious to see if my status update. Okay, so you can see that my status is updating right now. Oh, I saw some folks are at 4 already. That's pretty cool. Yeah. All right, so why, oh, okay, I saw it's a torrent hunter. Well, you're pretty fast. You're like already at the level 4. You finished the whole lab. That's pretty cool. All right, I hope that you're enjoying what you're learning so far. And I'm gonna take a quick break because we are waiting for the deployment. In the next section, we're gonna learn how to build bidirectional multimodal agent with the Gemini Live API. So yeah, hope you're enjoying what you're doing so far, and I will see you in 5 minutes. building this app, let's first understanding our architecture for the system we are trying to build. So this whole system is first we have this React frontend. So the React frontend is the cockpit of your ship. And then it captures the live video from your webcam, the audio from your microphone. And then we have a backend. So backend, we're building this with Fast API and Google Agent Development Kit to manage all the logic. And for the multimodal AI agent, the brain part, we're using Gemini Live API. And we're going to explain that really soon. So the Gemini Live is able to understand the video and the audio, the streaming simultaneously, so that AI is able to see and hear at the same time. And then we have this bidirectional WebSocket pipeline that's able to creating this consistent full duplex low latency connection. And you may wonder, okay, what are the four duplex? I feel like if you're new to bidirectional live multimodal agent, maybe you just hear a lot of new terminology. And don't worry about it. We're going to break it down. We're going to start from simple so you will understand what are those technology and why we're using those technology. Okay, let's start from very simple concept like a simple voice agent. You know, to talk about simple voice agent, like a simple voice AI, we want to first talk about what are the traditional architecture look like. So traditionally, you know, when you talk, you will capture the audio, and then you will send it to the speech to text, and then you will take that transcript and then send it to LLM, and take the LLM's text response and run it through text to speech. That is why at the very beginning, when I mentioning, you know, Omni app and the normal texting textile AI agent, even though we're adding the image or audio or like as an input, if it's still processing it as a text information, I wouldn't say it's not like processing things natively. Because, you know, with this traditional architecture, each step is adding time, it's adding latency, right? So if you're talking, if you just text, if you have text in, text out, you probably, it's not that obvious to you, but if you're actually talking to an agent, and the agent is having a conversation with you, when it's processing, when it's waiting for a long time, it's very noticeable, it's bad connection. So how do we fix it? And then to fix it, we need to understand these two modes of communication. And that is also the full duplex we were mentioning earlier when we were explaining the architecture. So what are full duplex? What are half duplex? And if you think about half duplex, you can think of it like a walkie-talkie if you have experience with that. You know, with walkie-talkie, it's like you talk, you release the button, and another person's talk. So while they're talking, it cannot hear you at the same time. You can just say, oh, hi, I'm at Annie's workshop, and another person say, oh, copy that. You cannot have a real-time conversation. And for the full duplex, it's different. Full duplex is like a phone call. You can see on the page that we have one person, we have both sides are talking to each other simultaneously, and you can interrupt mid-sentence. And there's no button. So for example, if someone say, hey, I'm listening to this Annie's multimodal AI agent workshop, another person can interrupt them mid-sentence and they don't have to press the button. So full duplex is harder, however, it feels more natural. It make it feel like a real person. You feel like you're talking to a real person, right? So to enable that, we're using Gemini Live API. So Gemini Live API is directly able to processing. So instead of traditional pipeline that you have, like you have text to speech, speech to text, you have those blocking pipeline. So Gemini Live is you can understanding the raw audio in, raw audio out. It will process audio natively. So that means if you're talking, it's not only able to understanding what you're speaking, it's able to also capture the tones, it's able to capture the hesitation, it's able to capture, oh, you sound very passionate about certain things, right? So it will capture more information than simple transcription. That is very powerful. And with that, we're also building, today we're also using Gemini, we're building this Gemini Live API also with Google Agent Development Kit ADK. So you're already familiar with ADK earlier today that we're building this multi-agent system with ADK. But you may wonder why with ADK. So you can simply using the API. You can using GenAI SDK. So ADK just provide you with more support, and you will learn what are support that provided by ADK. So to learn that, first you need to understand the concept of ADK. So here's an important concept, runner. So runner, it manages this life cycle and here's the event. If your user asking a question to the agent, say, oh, maybe now is lunchtime. You can ask, what should I eat for my lunch, right? And then this runner is having this event processor, is processing everything as an event. So no matter is agent like LMs making a decision using a certain tool, they all process as an event, and we have this event loop over there. So runner power up this whole agent so that your agent is can start working. It's like an engine for your agent. And then this runner also connect to the service. So here, service, if you still remember from last level that we talk about state. So for the service, basically we track the conversation state. I'm talking to you right now. You're listening to my workshop. This whole conversation, they can be tracked. Everything can be saved in the session. And important things in this conversation can be saved at the state, and state can be passed to a different agent, can be passed to another tool. So service is where manage all the history, the memory, manage all the state to maintain a multi-agent system. And here you can see it's connecting to the storage on the very right. You can also use there are many ways of managing that. So this is the concept to understand better about how does ADK support bidirectional multimodal agent. So now you understand the runner, you understand the session state. So now let's take a look at how everything's working. And so ADK have this something called live request queue. What is live request queue, and why we need this live request queue? So in a live bidirectional live conversation, the browser is sending the audio. For example, it's every 16 milliseconds or so. And then the ADK runner, remember ADK runner is the engine, right? So the ADK runner consumes those frames, but they're running a different async task. So for example, if one event is slow, it doesn't stall. You don't want it to stall another. So you can essentially think of it like a sushi conveyor belt. I hope that doesn't make you too hungry, or it make you. Oh, it's nice that we bring this up during the lunchtime. So you can think of this as a sushi conveyor belt that the chef can put the plates at the one side, and that is the browser sending the audio, sending the video, sending all the information. And then you can pick the plates from the other side. That is how AI consuming it. And neither of them have to wait for each other. They can just doing this at the same time. And that is the live request queue. So that means with this queue, our servers can run two parallel tasks at the same time. So we have this upstream task that you can read everything from the browser. You can push things to the queue. We also have this downstream processing that we can read from runner and forward the event back. And they're completely decoupled, and they don't have to wait for each other. So, and now just to summarizing them, so that there's two things that's very worth mentioning is we have different type of input with different behavior. So for example, we have this send real time. This is for the continuous streams. For example, if you keep talking, or in the demo I just show you, I give the camera like different hand gesture, and it need to understanding my finger, like my hand situation. So you will need to keep track, like you want to keep sending a continuous stream so that agent can processing and understanding it. So that is a real time information. We also have send content. So send content is for discrete action. For example, if you have image snapshot or text image, you can just hitting send, and then it will trigger reasoning immediately. So all of those flow into this live request queue, and they're first in, first out. That is the nature of the queue. And from there, ADK runner will feed everything to Gemini Live, and Gemini Live can processing them. So now, if we want to put them together, is we have the first step, this runner. Start with this streaming mode. So want to make the streaming mode to be bidirectional, so that it's able to, doing things asynchronous in parallel at the same time. And then we're pointing at our live request queue. And then we can say, so that is how to activate the full duplex pipeline. And then on the browser side, the browser data arrives at the WebSocket, and the server side receive it and convert it to the live request object. For example, we have the send content for text and send real time for audio. So we are basically trying to put everything at the sushi so that I can put them on the sushi conveyor belt. So you need to have something to convert them to the live request object so that you can put them on the sushi conveyor belt. And on another side, the runner pulls from the queue and then send this request to the Gemini Live, and response come back at the event. So the key is we have the sending and receiving happening concurrently. So the upstream never wait for the downstream, and the downstream never wait for the upstream. That is the bidirectional streaming in action. All right, so now you probably have, there's a lot of information going on, and you probably hopefully have a better understanding of what is bidirectional multimodal agent. And we can start by building them in our lab. So to start with our lab, we can go to our level 3, building an ADK bidirectional streaming agent. And here, this is what you will build. So as always, let's start by set up your environment. So I'll just copy this command. I will go to my Google Cloud Shell. So right now it's lost. It's pretty common because it's already passed like an hour or so. So we need to usually refresh it, refresh the token, re-authenticate. Let's see. Oh, I'm gonna refresh the whole page just to making sure. I also recommend you to refresh the whole page because it will also refresh the token for you. So it's not, you're not like expired with the token. So if, I don't know, I'm gonna wait. So if it's still processing, I might wanna restart my Cloud Shell. I'll see. So there's the option for you to restart. So if something's not working for you, or you find your Cloud Shell editing is weird, you can always try restart to reboost the VM for it. So now I'm opening this, and I'm gonna paste this to my terminal. So right now, here it doesn't have my project ID, but if you do it earlier, it's already saved it, because right now the environment, because I already refreshed it, it doesn't have the environment and everything remembered for me. So I need to put the ID again. So I need to grab the ID. Usually what you can do is, I'm gonna go to this Google Cloud Shell, and Google Shell in the project picker over here, you have this project ID. You can also go to this Quickie Lab page and then grab your project ID from here. Either way works. So making sure you put the correct project ID for it, and it will save your project ID, and making sure you will configure this project ID. So this gcloud configs that project is making sure to set the project ID correctly. So now you can see that with this yellow font over here, I'm setting up the project ID correctly. For those of you who might run into that error right now, because we are already, over maybe 2 hours or so, so maybe it's not authenticated with your project ID. So it's very important for you to run this command to configure. So making sure this project ID align with the project ID in your Quickie Lab. All right, so next, once you set your project ID, we need to enable the related service. So the service we are enable the Google APIs, artifact registry. So artifact registry is basically we want to have a containerize them and deploy them to cloud. So we want making sure to configure this artifact registry on the cloud so that we can put the image there and then deploy to Cloud Run. And then for the cloud build, you probably saw it earlier that we use cloud build to see the building process. So IAM is just setting the permission, and of course we want some AI platform API. So here is how you can enable the different service. It usually takes like a minute or so to enable all the related service. And again, in this stage, we want to install the dependency. So for the dependency here, UV-Sync, you're probably already familiar with it. It's like install the dependency, and you can go to the level 3 and then check the Pi project Toma file to know the dependency for this project. You know, I noticed that we have the duplicate WebSocket. We should remove that. But essentially, we have WebSocket, Fast API, and Google ADK. So once we have that configured, we want to making sure we install all the necessary dependency. We want to run the verification script. So verification script is making sure everything is set up correctly, especially this Google Cloud project, because again, like if you're not typing the project correctly, you cannot run it smoothly. Yeah. So now it says everything is correct, and I feel safe to go. And what's next is I want to configure and understanding the WebSocket. So you may wonder, you know, what is the WebSocket? Like we covered what is the WebSocket earlier in the presentation, but for those of you, so WebSocket is very common or very commonly used in a live streaming situation. But so everything you know, usually you do normally on the web, it works like ordering at a counter. For example, you ask, and then server handle it back, and then they ask and answer. It will ask, answer, and hang up. So that is like HTTP request. So the HTTP request is perfect if you want to load in the page, but when it having a live conversation, AI wants to talk before you have finished, and you want to have ability to interrupt. So a WebSocket fix that with one move is like the browser and server open one connection, and they keep it open. It's just like it's like a phone call. So that's the full duplex we were mentioning earlier. And so here we are we can see the implementing the WebSocket hook, and it's essentially to fill the void with the to call and audio call. So what you want to do is first you want to replace how they're handling this message. So similarly, you're going to this way back home level 3, use Gemini socket. So I'm going to my terminal, I paste it over here. Okay, I shouldn't paste it. I should search the file. Oops. Oh, I'm searching the file. Okay, so let me search this file. Okay, great. Okay, I guess I should make a silly mistake. So I search this file, I open the use Gemini socket, and then I need to search first replace handle message. And the next is I want to making sure I'm putting this information over here. Again, when you do this paste, it's very important that you keep the indentation correct. Right. So you may wonder what we're doing like right now is we are doing this replace handle message, and you may wonder why we're doing this and what we're doing this right now. So basically, this is like the year you want to. So every time the agent it's think or speak. So and we ask one question. So is this an action or is this a voice? If it's a function call, then the AI use our tools. It will see the finger, and then it will grab the count, and then it will light up the lock. So if it's the audio, that is the AI voice, and then we will play it. So here, basically, it's like years we're handling this message. This is what we're trying to do. And the next is we want to processing this video and audio data. So again, in the same file, I'm at use Gemini socket file, and then I'm looking for replace capture audio and video file. and pasting this over here. Again, be careful with the indentation. And let's take a look at, so first you have this ear. So next thing is, what we're doing right now is when you want to capture audio and video it's like the mouse and eyes of the agent. For example, if you want to turn on the camera, that's what pops the permission like prompt. If you want to turn on the mic, so every chunk of this audio information, we want to wrap it. And then, for example, with the camera loop, so every half second, it will grab a frame as a photo and send it to it. So those are basically acting like the eyes. And so before we have the ears, these are basically the mouse and eyes with WebSocket. All right, so now let's try to do the diagnose check. So remember, right now, if you take a look at this, I am a mock server, I do nothing, so it's a mock server. You would not expect this is working because we haven't implemented the agent code yet. So this is simply just diagnose the WebSocket and everything's working. So I'm gonna copy this and paste it to do the npm run build to start the build. And let's take a look at what does the mock server look like. So first we want to build the cockpit interface. That is our front-end React code. And then we want to start our mock server so that our React code connecting to the mock server. Let's see. So now, right now the reacting is building. Okay, we finished the front-end React code, and then the backend. Let's start the server file. Again, to start a server file, you can either directly click on this A0A0 link, or you can go to the top right. We have this preview. You can preview this A0A0 directly. So as you can see, this is similar as what we're seeing. So I can see.
System connected. Audio and video streams received.
Yeah, so it is starting. However, if I say scan or 3, I'm calling it, it's not reacting because it's actually the mock server right now. So it's expected that it's not reacting. But I just want to spin up this to making sure the whole the front and back end connection is working. But you may wonder why we want to have a mock server. What's the point of having the mock server, right? So that's a great question. If you have that question, because because we just built the cockpit, but the AI brain doesn't exist, and we want to build the AI brain next, the multimodal AI agent brain. But the mock server is then in so that it speaks the same WebSocket language as a real backend. It doesn't do AI, so basically it helps catch, making sure this the ear, the eyes, the mouse working, and then once making sure it is working, we want to add in the AI logic so that we can add in the logic step by step. Right. So now we are knowing everything's working, and the next thing is let's build this multimodal agent. So to build this multimodal agent, we're using this ADK, and I already mentioned, for those of you probably already familiar with ADK, but we're building this with this ADK, and let's take a look at how we're building this brain. So again, I'm copying this path and going to the file. So now I'm looking at the biometric agent file. I'm replacing this instruction of the biometric metric agent. So again, this is the ADK agent. So the instruction is, I just want to making sure the indentation is right. Yeah, so the instruction is your AI biometric scanner, and this is the behavior loop. So you need to first wait until this voice trigger. So that's why I'm like talking to the agent to say scan, or oh, it's a verbal trigger scan or visual trigger with my hand. And then it will do the action as expected. So this is the instruction. And the next thing is we want to making sure to use a Gemini Live model. To do that, we need to first find the replaced model, and I'm using the Gemini 2.5 Flash model. So Flash model has some new model right now. By the time we were making this lab, it was like making before, so we were using 2.5, but you can using latest model too. To change the model, you simply just need to change this line. And then the next is we want to making sure updating the tool calling. So we're making sure stay at the same agent and replace the tools to do the report digit. So this tool, just like what it says, it's based on how many fingers it is detected. It will send the detected finger count to the system, and you will understanding how many finger. And lastly is in the tool configuration, we want to attach this tool to our agent, so that now my agent is called biometric agent. It is using this Gemini live model, and it's using this report digit tool so that it's able to count my how many fingers on the screen, and then it's able to response back to me. So now let's take a look at this brain, like how this let's testing this brain, how this brain work. So let's just copy this and paste it to the terminal. So what it does is, again, we are making sure every environment variable is configured correctly, and we start with ADK web to start our web interface. So you can start web preview, and you can change web port with 8000, or you can directly click that link to open the ADK web UI. So to open the ADK web UI, what you do is you need to first you need to open the camera, and then you need to hold up the finger and say scan. And let's give it a try. I'm going to open the camera first. Hi, scan.
Biometric match, 3 fingers.
Cool, scan.
Sensor error,
Okay.
hold hand steady.
Scan.
Biometric match, 2 fingers.
Cool. So you can see that it is reacting and like triggered by scan or the raise of the hand, and it's able to understanding the number, like able to respond with the number of the finger. It's pretty cool. I'm gonna close this. I'm gonna turn Control C for the yeah. So that you just see that we successfully built this ADK AI brain. So what we've done so far is we built our front-end React, and we are making sure the mock server, the connection is working, right? And then we're building this multimodal agent. And what's next is we want to making sure this multimodal streaming is working, right? Because earlier we were talking about this, we want to making sure we have the upstream and downstream, they're working at the same time, and they're not blocking each other. They're happening at the same time, so that you are able to processing your voice, you're able to interrupt it. You can have mid-sentence. You can you will talk to the agent like having a real conversation. So this non-blocking, this live bidirectional is the key, and how to make that happen. And so the key is we're making sure we configure our service and our runner successfully. So let's go to the main file and copy this. So here I'm at this main file, and I'm finding this replace runner config file, and I'm paste this. So here, basically what I've done so far is I'm creating this session service with in-memory session service, and runner with runner. Remember, runner is like we just presented earlier, that it is like an engine for your whole agent, and then the service, the session service is basically saving everything you've been talking about. And right now we are using in-memory session service. So ADK with session service, it default has in-memory session service, you have database session service, you also have agent platform session service. So in-memory session service is like everything we've talked about, you will save on the RAM. It's instant, it's fast. However, when you reboot the machine, you will lose all the context. And with a database session service, usually you can define your own database solution. For example, you can store things in like Cloud SQL, in a SQL database, or you can store things in different like a Spanner or the Graph database or different type of database, or you can store in a local SQLite or any type of database you want. You can manually manage how you store everything in a database session service. You can also define your session service with agent platform session service. So with the agent platform session service, it's like Google Cloud managed database for you, that you will store things to cloud. So Google Cloud has an agent platform session service with the memory bank that you will manage everything for you. Yeah, if you're interested, you can like check out the different type of session service at the ADK doc. And here we are using in-memory session service because we are doing this live bidirectional multimodal agent, and then we really want to have a live or good user experience. We want to hear voice back immediately, because if you want to do a database fetch or you want to fetch from cloud, Google Managed service, they all takes time. So usually for a live conversation, in-memory session service is the fastest and it's instant. So usually we start from in-memory session service for a live session, mostly for the latency perspective. But however, you can definitely architect your system differently. And once we configure that, and next is in the same main.python file, we have this replace session in it. And what we've done is making sure that we have session initialization in the WebSocket over here, so that the session will capture all the necessary information, and then you will capture this audio transcription and everything. And the next is replace to run the configuration, and the next is replace the live request queue. And this live request queue is ADK, so it's provided with an ADK framework that is exactly what we mentioned earlier, that we have this sushi conveyor belt that it will handling this conversation request for you. So if you can definitely build things with GenAI SDK or using API directly or different agent framework, but I think with benefit of ADK, one benefit of using it is it's providing this live request queue to manage the concurrent bidirectional communication for you with this structure. So what we want to do is we replace it and paste it over here. And the last thing is we want to making sure it's able to sort the response. So again, we are copying this, and then we are making sure that once with all the information, it will sort it correctly before it's terminate the session. So with that, we are just basically finished. What we've done so far is we understanding what is the WebSocket. We configure the ears, the mouse, the eyes for WebSocket, so that first at the step 3, we understanding the front end and back end connection. We understand how WebSocket enable this the streaming connection. And the step 4 is we are understanding how to build a multimodal agent with ADK by using the Gemini Live model. And step 5 is we configure the runner, the session, the live request queue, so that we're putting things together. And with that, you're able to build any I think this is the mental model you can carry over to build any type of bidirectional live multimodal agent. And before we wrap up, let's try to testing this and to see if everything's working with this system we're building. So what we're doing is we'll copy this and paste it to the terminal. So this time, I can just click in this. You can also open it. So this is the application. This is not the mock server. This is the actual server. So I need to actually test it to making sure it is working. Scan.
Biometric scanner online.
Scan.
Biometric match. 5 fingers.
Scan.
Biometric match. 1 finger.
Scan. Maybe I'll do 2. Scan.
Biometric match. 2 fingers.
Wait, it's not matched. Okay, 3 finger. 3. Scan.
Biometric match. 3 fingers.
And can you finish? Scan. Okay, great. So it looks like it's able to capture everything and it's working. So once we testing everything's working, what's next is we want to deploy them to production. So if you take a look at how the deployment is, so here we want to deploy, we put the whole system, we want to deploy the whole thing to the Cloud Run. And to do that is first you want to build a Docker file and basically to containerize them and then deploy into Cloud Run. So similarly to the step before, but the last step is we're using the ADK run to deploy the agent. But here we want to containerize the whole system and then deploy them. So that's why the deploy strategy is a bit different. So now I'm trying to run in those commands to finish finish this whole deployment process. By this command is basically first creating a Docker file so that we can build this image, and then the next one is making sure we have this project ID set up correctly, and then so right now the project ID is the correct one, and making sure every parameter is set up correctly. Otherwise, your deployment process may not set to the right parameter. So once we are configure those, we just need to run gcloud run deploy to deploy to our Cloud Run. So I'm gonna just making sure things finish. Yeah, but the whole deployment gonna take a while, and it probably gonna take 3, 5 to 7 minutes. And I probably wanna just while we're waiting, I can just quickly wrap up about what we've done so far with our slide content. So like early this morning, before you're working, I promise you that I show you the demo and you will know how to build it. And you not only know how to build it, you also know the concept of Omni app. And so that you can have this concept carry over to build any multimodal agent you want. So what we covered so far is we covered this level 0. And first level 0 is Express. And your app learn how to create things. It's able to learn how to create consistent image. And we are creating the same image, same face across every generation. So I remember, at the level 0, we covered the multi-turn generation in the same chat session. We also covered different approach, including fine-tuning or including the multi-image reference and more. We also covered the variable, some tricks about security thing with variable injection and prompt injection and more. And for the level 1, that is the perceive and reasoning part. You learn how to gather and decide. So basically in the level 1, you orchestrate a multimodal agent, and that multimodal agent is able to perceive, understanding the image, the video data. So you understanding how to process them, how to build a multi-agent system to have a different specialist, make a decision together and voting and make a final decision and do the reasoning together. And at level 3, you're building your bidirectional live multimodal agent. It's a live agent. You learn how to run things in the real time. You learn how the agent can see you, can hear you, and you can talk, you can interrupt. That's the most important thing. And then those both direction at the same time. So, I hope that you learn a lot from this 3 workshop, and you not only learn how to build the demo, you also learn the concept of multimodal agent. You can build your own Omni app. Yeah, all right. So I think that's it about this whole workshop. I really hope you enjoy the process. And if you have any question, you can scan my social, and then you can stay connected or ask any question to me. And thank you so much for joining this workshop. And I hope I can see you next time. Thank you.